Today I'm going to be talking about solving for variables. Now remember, a variable is a letter. For example, x, y, z, as opposed to a number which we call a constant. A number, for example, 1, 2, 3. These numerals are constants because they always represent the same value. 1 always represents one item. 2 items. X, depending on the equation, can vary. Sometimes it can be 1, sometimes it can be -1, it can be 3.5. It varies, so we call that a variable. So how do we solve for variables in algebra? Well, the first major principle when solving for variables is we must always isolate the variable. This means in the equation we want to get the variable all by itself on one side and everything else on the other side. Now how do we isolate the variable? Well, we isolate the variable by doing the opposite. So for example, if something is being added to the variable, we would subtract the same amount to isolate the variable. After we do the opposite, in order to keep the equation balanced, we must always do the same thing to both sides. So after I do the opposite, I'm going to do the same thing to the other side. Otherwise, the equation will not be balanced. So when I'm solving for variables, which is a letter, we isolate the variable. We want to get it all by itself. We do this by doing the opposite, or the inverse operation. So the inverse operation of addition is subtraction. The inverse operation of subtraction is addition. The inverse operation of multiplication is division. And the inverse operation of division is multiplication. And then anything I do to one side, I must do to the other side. So let's look at some sample problems for solving for variables. We'll start off with a very simple problem. X plus 1 equals 2. This is the variable. Notice it is not isolated. 1 is being added to the variable. I want to get the variable all by itself. I want to isolate it. Since there is an addition occurring, I'm going to do the opposite, which is subtraction. I subtract 1. Notice that will equal 0. 1 minus 1 equals 0, so that cancels out. Now x is all by itself on the left-hand side, but now the equation is not balanced. So anything I do to one side, since I subtracted 1 from this side, I must do the same thing from the other side. I must subtract 1 from the other side. Now I have x by itself equals 1, which is my answer. I can check this answer by plugging in my answer to x. So I replaced x with 1. 1 plus 1 equals 2, so I did that correctly. Let's look at another problem. Let's say I have y minus 2 equals 4. Notice y is with -2. I'm going to do the inverse operation, which is addition, to isolate my y. -2 plus 2 equals 0. That cancels it out, but anything I do to one side, I must do the same thing to the other side. Y equals 6. I checked it. Replace y with x. 6 minus 2 equals 4. I did that correctly. What about multiplication or division? Well, let's say I have 2 times z equals 8. Notice there is no symbol between them, which signifies that there is multiplication occurring. Anytime there are two numbers or variables next to each other without any symbol between them, we know that that is multiplication. So I want to isolate the z, so I do the inverse operation, which is going to be division. So I'm going to divide by 2. 2 divided by 2 equals 1. So I'm left with just z, or 1z on that side. But anything I do to this side, I have to do to the other side, so I'm going to divide the other side by 2. 8 divided by 2 equals 4. So I have my answer, z equals 4. I can check that with my original problem, which was 2z equals 8. I'm going to replace z with my answer, 4. 2 times 4 does equal 8, so I did that correctly. We can do the same thing with division. If if I have 10 divided by a equals 5, this one is going to be a little bit trickier because notice 10 is just being divided by a. So in this case, in order to get a isolated, I'm going to have to move a to the other side. Otherwise, a will remain in the denominator, and I will be left with 1 over a. So I'm going to multiply both sides by a. That will cancel out a on this side. Anything I do to one side, I have to do the other side. Now I have 10 equals 5a. I want to isolate my variable. I have multiplication occurring now. So I'm going to do division. Division. 10, this cancels, leaves me with just a equals 10 divided by 5, 2. A equals 2. I can check my answer. 10 divided by 2 does equal 5, so that is correct. What if we have several different operations occurring? For example, if I have 3x minus 1 equals 8. Anytime you have several different operations, I want to do the inverse of the order of operations. The order of operations, when I'm solving a problem without variables, I start off with multiplication or division, left to right, and then do addition, subtraction, left to right. I'm going to do the inverse when I am solving for a variable. So first I'm going to do my addition or subtraction. Notice this is subtraction, multiplication, so I'm going to do the opposite of what I would do if I was solving a normal equation, and I'm going to do addition, subtraction first before the multiplication or division. The opposite of subtraction is addition, so I'm going to add 1, negative 1 plus 1 equals 0. That leaves me with 3x, but anything I do to one side, I must do to the other side. I add 1, that equals 9. Now I have multiplication. I do the inverse, which is division. Divide by 3, divide by 3. This makes 1. 9 divided by 3 is 3. I have isolated my variable, x equals 3. I can double check that by plugging it into my original equation. 3 times 3 minus 1 equals 8. 9 minus 1 does equal 8. So I did that correctly. So the whole goal, when I have any type of problem with variables, is to isolate the variable, to get the variable all by itself. I do that, one more time, by doing two major steps. I isolate the variable first by doing the opposite. So if I have something being added to the variable, I subtract. Subtracted from the variable, I add. Multiplied by the variable, I divide. Divided by the variable, I multiply. Second, I do the same to the other side. If I have several different operations happening, I start with addition or subtraction, then I do multiplication and division. That is how we solve for variables.